Hello and welcome to the November Recreational Astronomy Night meeting of the RASC Toronto Centre. My name is Paul Markov. I'll be your host this evening, introducing the speakers. We are at the Ontario Science Centre in front of a live audience of about 15 to 20 people. To our online viewers, a reminder that meetings have resumed in person here at the Science Centre, so if you can join us next time, please do. For those who definitely cannot be here, not to worry, the online streaming of the presentations will continue, thanks to our top-notch AV team, comprised of Andrew and Betty Reed, Ward Legros, Enu Cholucci, and Reza Mohammed. And as you know, I'm always on the lookout for presentations for following meetings, and I'm glad to say that the December meeting is booked up, but the January and onward meetings are wide open. Meetings are held on the first Wednesday of each month. If you have something in mind, please let me know. The presenters for this evening are Andy Beaton, presenting the sky this month. Frank Dempsey will talk about variable star photometry using a photoelectric photometer, still valuable after 35 years. And then we'll have Chris Vaughan and Tony Horvatin joining forces to share their memories of Blake Nancaro, who was a very active and prominent Toronto Centre member, and unfortunately he recently passed away. Tom Luton will wrap up the meeting with announcements. We should be done by about 9:30 this evening. If you're watching us online and have a question, please enter your question in the chat box, and Ennio will ask the questions on your behalf. For in-room questions, please put up your hand, and I'll have to walk over with a microphone so that folks online can hear your question. And also, if, show of hands, anyone here for the first time, whether you're a member or not, doesn't matter. We have a couple of people. Very good. Welcome. And then for the folks online, please let us know where you're from and say hello through the chat box as well. So let's get the meeting started with Andy and the sky this month.
Hello, my name's Andy Beaton. I'm an amateur astronomer who observes between the trees and streetlights of downtown Toronto. And I'm here once again to talk about what's going on in the sky for the next month. People who've heard my talk before will recognize the list, the big picture, key dates, the moon, planets, something in the deep sky, a double star, a variable star, and whatever's going on in the world of spaceflight over the next month. So starting with the big picture, if we go out tonight and it miraculously gets clear, we'll be able to see all our favorite summer constellations disappearing into the west, and a decent parade of big planets. We've got Saturn, we've got Jupiter, we've got Pluto, but you're not going to see it, and all the usual fall constellations showing up overhead. If we show up at 6 in the morning before our next meeting, we get a very different view. We're going to start seeing the spring constellations already showing up before dawn. And anybody who's awake at that hour is definitely going to see Venus, which is absurdly bright and completely obvious to anybody having a look at the sky. So we're at the time of year where the nights are getting longer. Good news for anybody doing any photography, needing long exposures. Twilight is ending at around 7:30 Eastern Daylight Time tonight. Starts again at 6 Daylight Time in the morning. By the next meeting, twilight will end at 6:04 Standard Time. Notice the change there. And starting again at 5:37 Standard Time in the morning. So yeah, we did get a shift in the clock coming up over the next month. Keep that in mind when you're planning your observing. So important dates coming up. November 13th is going to be the new moon. The moon is at apogee on November 6th and again on December 5th, twice in the same meeting period. And then perigee, the closest point, on November 21st. As always, I will suggest, if you're looking for an amusing project, take pictures of the moon, at both apogee and perigee, and compare it. If you have figured out how to take pictures of the moon using an Apple iPhone without getting a terrible bit of glare showing up, let me know offline, because I'm intensely curious about it myself. Full moon, November 27th. Jupiter at opposition on November 3rd. Uranus at opposition on November 13th. And we've got the Leonid meteors coming up on November 18th. So the moon, we love it and we hate it. First quarter coming up on November 20th. Full moon on the 27th. Looks spectacular, but it's a nightmare for anybody doing any deep sky observing. Whoops, sorry. Last quarter, we got two last quarters this cycle, November 5th and December 5th. The new moon on November 13th. Now, November 19th, we have the lunar X happening. And for those that don't know, there's a pair of craters situated side by side. When those crater rims are illuminated at exactly the right angle, it looks like there's an X on the surface of the moon. Doesn't mean anything, but it's really cool. The lunar straight wall, Rupes Recta, on the evening of November 21st, gets illuminated at exactly the right angle. Another feature of the moon that looks really cool. So we have all the usual planets appearing or not appearing. Mercury will be appearing in the evening, low in the sky in the second half of the month. It's not going to be easy to see, but it's worth seeing. In the morning, Venus is unmissable. It's extremely bright and obvious, and if you have a telescope, you can check it out as it changes phases. Mars, however, is invisible this month. It's on the wrong side of the sun. We're not going to see it for this month, and probably not for the next month either. The big gas giants are going to be the ones we love the most this month. Jupiter is visible all night long, dawn to dusk. On November 3rd, it's at opposition, which means it's on exactly the opposite side of the sun from us. It's, if not the closest it gets, it's close enough to the closest it gets. It's going to be a great time to look at Jupiter. It's fairly high in the sky. It's an excellent time to go and look for the Great Red Spot, which remarkably few people have seen. It's kind of a pale salmon spot rather than great and red, but it's worth looking for, and it's actually something scientists care about, keeping track of when it hits the meridian and tells us just how weather on Jupiter is behaving. Saturn, by the time twilight's over, it's almost straight south from us. Also worth seeing, good tourist object for your friends and family who haven't seen it. If you've got anybody that you really want to show them the spectacular sights in the sky, those two planets are always top choices. I'm sorry we had this meeting tonight instead of 2 nights ago. I would have told people to take your telescopes out to the sidewalk for Halloween and give the kids a treat. As it turns out, it's cloudy anyway, but it's always a nice idea. Uranus and Neptune also very well placed this month. Uranus rises not long after Jupiter and is visible all night. It's in opposition on November 17th. Unfortunately for us mere mortals, there's not a lot to see on the surface of Uranus, at least with our telescopes, but the moons of Uranus are always a target for people with serious equipment. Neptune is kind of halfway between Jupiter and Saturn on the Pisces-Aquarius border. Also interesting to see, it has a much more interesting moon than Uranus does. It's got Triton, which is in reach of most telescopes, and tracking it from night to night is probably a worthwhile project. The minor planets, it's kind of a write-off this month. Pluto and Ceres are both too close to the sun for us to see. Of all the other minor planets, I guess the only one even remotely in reach for people with top rank equipment and the ability to take long images, Eris is in Cetus. 18th magnitude, I guess, is doable. My telescope's getting nowhere near that, but I know people out there have better equipment than I do. So I always like to throw in something for people who want to go and look in the deep sky. The Perseus double cluster is the one I've picked this month because it's so obvious and bright and makes a really nice show off to your friends and family object. I've got two open clusters side by side. Here, hang on a second. There it is, that's what it looks like. Two bright open clusters side by side in the sky. They're actually a few hundred light years apart, but they're both within a single eyepiece view for any wide-angle telescope or a pair of binoculars. Under dark skies, you can see them with the naked eye as kind of a fuzzy blob. Once you get binoculars, then you start seeing the stars. And it's actually a pretty good target for looking at in the city because stars do a good job of getting through all the light pollution and dust and haze that we live with. So if you're an urban observer, I would put it on my target list. So there we go. That's what it looks like. Again, there's some interesting red stars in amidst all the bright blue ones. Now, if you're a more advanced observer, there are 5 variable stars of note within these two clusters. RS Persei, AD, FZ, F403, and V403 and V439, all within Perseus. I'm going to pop back here for a second. When I look at this, I'm seeing all kinds of dark blobs around there, which, as far as I can tell, are not cataloged dark nebula, but I'm super suspicious about it. So if you're a serious observer, set up your camera, get some long-term exposures, and tell me if you think we're looking at dark nebula all around there. And if, if you're an advanced observer, let's be honest, the double cluster is not that exciting or interesting. You can always just pop over to M45 when no one's looking and check for nebulosity. That's one of the challenge targets I've been looking at for a long time, and I'm never sure if I've seen it or I'm just seeing unclean eyepieces. Comets and meteors. We have meteors. We have the South Taurids coming up. Actually, we have the South Taurids going already. They peak on November 6th. We get about 10 per hour. The North Taurids also already on their way, peaking around November 13th, 5 meteors per hour. It's not really a lot, but if you're out there observing and you see them, they are said to be bright meteors. So, trace them back to where they came from, see if you're spotting meteors from one of those showers. More interesting are the Leonids, 20 meteors an hour, peaking on November 18th, and more or less starting in a couple days. It's not one of the big ones. It's not the Perseids or the Geminids, but it's one where if you're under a dark sky, you'll see some real meteor action over the course of the night. The November Orionids are coming along mid-month and extending into December. That one, we're looking at 1, 2, maybe 3 meteors an hour. Not a big deal, but if you're out there, you can always see them. Comets, nothing too spectacular. 2P Encke is the brightest. It is unfortunately really close to the sun right now and will be for probably the rest of the year. Keep it on your list for something to look for in the new year as it gets past the sun and starts showing up again. The other ones, C2021 T4 Lemon in Ursa Major, 103P Hartley and Hydra. The next two, P1 Nishimura and V2 ZTF, are only visible from the southern hemisphere. Last year, I wouldn't have bothered telling you about this, but I've discovered since that we have viewers from the southern hemisphere, from way south of the equator, who will have an opportunity to look for these comets, so I hope they get a chance. And then just over the 12 limit that I arbitrarily set myself, 12P Pons Brooks, 11.7 in Hercules. I think that one is for people who are obsessed with comets or have never seen one before and want to check it off their list. Also want to point out that solar cycle 25, solar activities on the rise. I think there were, recall, something like 60 sunspots this week, so keep an eye out for solar activity. I don't think there's anything spectacular going on right now, but keep an eye on spaceweather.com for maps and up-to-date information. So we have to do a double star. Delta Geminorum is the one I've picked, also known as Wasat. It's a triple star in Gemini. It gets 2 exclamation marks in the Observer's Handbook, which is pretty good. 3 is more spectacular than you can stand. 2 is just all right and beautiful. It's a yellow and red pair, 3.5 and 8.2 magnitude, 5.5 arc seconds separated. So any reasonable size telescope, probably 4 inches or up, you should be able to separate it. The third star is a spectroscopic pair with the primary, the 3.5 magnitude star. I don't know anybody who has a spectroscope, but I know some people do. I saw one at Starfest this summer. So if you have a spectroscope and you feel like trying to split out a triple star, there's a project for you. Now, obviously, I'm not going to do the sky this month without doing a variable star. I've picked R Canis Majoris this time, and what we have there is an eclipsing variable star. In this case, the star itself is a constant brightness, nothing too interesting about its star. What is interesting is it's orbited by a companion, and the companion gets in the way and blocks some of the starlight, and the brightness dims. It goes from about 5.7 to 6.3 magnitude, and it has a period of 1.1359 days. Now, what's interesting there is there are also subtle variations going on in the period, which could hint at another star in the system. The AAVSO, the American Association of Variable Star Observers, are the place to go for maps and reporting. I'll make one more observation here. A period of 1.1359 days is pretty fast. And I took a look at the chart, and it dips and rises pretty rapidly. What that means is it's hard to get good observations when you're doing it with the old Mark I eyeball. This would be an excellent target if you happen to be observing variable stars with a photometer. Stay tuned. We have another variable star. This one I've been watching for a little while, supernova 2023 IXF, or as we better know it, the supernova in M101. This one went off earlier in the year, and it's still steady around 14.5 magnitude. Once again, scientists are eager for your observations. Download the maps from aavso.org. Make a careful observation and report it, and you will be a scientist. So coming up in spaceflight, not a lot of exciting stuff happening this month as far as launches are going on. Starship launches are on hold for environmental assessments and reviews. The last launch was a bit of a disaster. That's bad news for those of us who are interested in the Artemis program. Starship is kind of a key component of that, and it will be worrisome to see what happens if Starship gets delayed any further. OSIRIS-REx is back with asteroid fragments. Pay attention to the news, see what is coming out from reports there. The ISS is passing over in the morning until November 8th, and then from November 14th until the next meeting, it'll be passing over in the evening. Heavensabove.com for times and locations. And of course, we're in a golden period for infrared images. The JWST is sending us fascinating new stuff all the time. The most recent one I picked up, and I wanted to show people, there's M1 in infrared. If you go to the NASA website, they've got an interesting comparison of infrared and visual images of M1. So check that out and keep an eye on other interesting stuff coming through the NASA pipeline. And I know you're wondering what to do if it's cloudy or you've eaten too much Halloween candy. Zooniverse.org has a lot of citizen science projects that you can do by your computer. Pulsar Seekers is a newish one. Gravity Wave Zoo, if you want to help in the search for gravity waves and understanding how they affect the universe. Backyard World's Cool Neighbors, you join in the search for brown dwarfs. And Blobs and Blurs, Extreme Galaxies and Clusters. Now, there are way more projects on zooniverse.org. I'm sure if you have a particular love of one particular niche of astronomy, there's a project there for you. So I recommend you go and have a look and find something good. And that's it. Questions? There's always a typo in my presentation, so I'm sure someone will kindly correct something I've said. Otherwise, you can contact me here. Thanks very much.
Thank you very much, Andy, for a great presentation as usual.
Thank you.
Do we have any questions in the room? Any questions for Andy? I'll bring you the microphone. No question. Andy was shaking his head. Yes, no questions online as well. Well, how about I ask you a question? Meteor showers. You mentioned the Leonids,
Yes.
right? It was about 20 per hour, I think,
That's
that
what-
you wrote.
yes.
Isn't the one that sometimes has these outbursts?
It does have outbursts, and they predict them from year to year. I have heard nothing about an outburst being predicted for this year.
Okay. The last I heard of was the outburst that I think Tony Horvatin and others watched at the CAO a few years ago. Was it that long ago? Right. Oh.
All right, well, in that case, I will suggest people make an effort to get out there on Leonid night. Maybe you'll be lucky.
All right. I guess that's it. Any questions by any chance? No? Okay. Thanks
right.
again, Andy.
Thank you.
Appreciate it. Okay, we'll go to fun facts because we need to switch over to our next speaker. So we'll be back in a moment. right, we're back, and our next speaker is Frank Dempsey, and he'll talk to us about variable star observing with a photoelectric photometer.
Okay, thanks, Paul. So we're all set? Okay. So the title slide says quite a lot. It's been 35 years, actually it's closer to 40 since I started using a photoelectric photometer for variable star observing. And so let's just see if we can advance the slides here. Give you some idea of what it is. It's this little hand-sized sort of object at the end of the telescope you see labeled on the picture I have on the left side here. It's what the scope I've currently been using for it. So a little photometer about the size of my hand, and you see it's in size in relation to an 8-inch or 200 millimeter telescope, and the HUD itself is sitting on the right to give you some perspective for size. But that is what a photometer looks like. I could just mention, before I got this, for several years I was planning to build one. And so there are numerous plans around, and photoelectric photometry had been in use for quite a few years before that, and there are various plans around it, and I was planning to build one, and I relied on a couple of people who knew quite a lot more about electronics than I did, and they gradually disappeared. One moved far away to a new job, and another one got married. So, and at about that time, mid-1980s, this commercially made unit became available. And I think I had a picture here somewhere. Oh, here it is, Sky and Telescope magazine, mid-1980s. So you see an ad, and so in those days, believe it or not, you would write a letter to the manufacturer or the address in the ad and ask for more information. So anyway, I eventually got a photometer and decided it's a pretty reasonable deal and pretty well built and had good reviews, and people were doing quite a lot of good science with it on small telescopes. So that's where it appeared first, Sky and Telescope. It just gives you some sort of idea of the picture of the layout of it. So you see on far left the nose piece that goes into where your eyepiece would go in the telescope, as I showed you in the back of that Schmidt-Cassegrain telescope. At the top is an eyepiece with a reticle. So a flip mirror directs the light up to the eyepiece so you can center the star, the target star, in the reticle, and then you flip the mirror out of the way, and then light path goes directly to the detector, which causes a digital readout to appear on the digital display, and that's the number that we'd record for the output of the photometer. And if you're curious about the electronics, here's on the right side, you see a picture of the back cover removed, and lower half, I put a little diagram, but didn't want to get into too many details unless you're really curious about it. It's basically a self-contained unit. In that era, there were numerous resources available by then for doing photoelectric photometry, and it was quite a well-advanced field that a lot of amateur astronomers were doing, and I thought pretty darn interesting. So there are various books. The journal on the lower right is the IAPPP. That was pretty well known too, and it was a quarterly sort of journal. And on the right is monthly or possibly bi-monthly newsletter from the AVSO PEP, or photoelectric photometry section. So there are quite a lot of good resources available to help get started and get going in it. There's another resource that's online, and if you're really curious, you could access this probably for free without needing to be an AVSO member. But the current photoelectric photometry observer's guide has quite a lot of information. In case you're curious, you want to look into more of it, you could. So it's the AVSO, and thought I should briefly mention what is the American Association of Variable Star Observers. So I'm not here to sell it or sell you membership in it or promote it, but I would just say that it's the prime organization, one of the main best well-known organizations in the world for collecting and encouraging observations of variable stars from amateur astronomers and professional astronomers. So quite a well-known organization. Didn't want to read off a lot of information, but there is on this slide if you're really curious. But aavso.org is the website. As I said, I'm not here to talk about it. It's just that the photometry I've been doing, I chose to do it with the AVSO photoelectric photometry program that they had in place, and it's still running. So to give you some idea of what's going on here, the idea is to collect observations of the brightness of a variable star. And here you see a light curve which plots the magnitude on the vertical scale and the date or time on the horizontal scale. So from left to right, I plotted here the past 400 days of a well-known star called Betelgeuse. So Betelgeuse is probably the best known red supergiant that's quite variable. It's quite well known because several years ago it dipped suddenly in brightness. And so the point of this chart here is it plots photoelectric photometry magnitudes and the green dots. And I should say that they're to a precision of 0.01 magnitude. And the best that a visual observer can generally do under good circumstances is about 1/10 of magnitude, some cases better. However, in this case, this also plots visual observations that people make of star Betelgeuse, and is vastly more complicated because you need comparison stars that are similar in brightness nearby and don't differ by too much so-called air mass or, or distance that allows a lot of extinction when one star is further away, too far away from another star to make a good estimate. And so a lot of other details, including the color, how it affects your eye or the detector. So you shouldn't be too surprised that you see here the visual estimates of Betelgeuse here are all over the place. They're quite wide. And so if you didn't have the photoelectric curve in green here, just imagine the black dots, and it would be quite a mess, and you would probably have a hard time saying, you'd say yes, it's variable, but have a hard time doing really good analysis of it. So just in comparison, I think the photoelectric photometry magnitudes are pretty darn precise, pretty good. So that illustrates the advantage. I think it gives you some idea of the advantage of photometer and photometry and why photometry is preferred for certain stars. So let's past 400 days. So I plotted another one. I won't show you any more comparison with visuals, but the photoelectric photometry magnitudes for the past 5 years approximately are plotted here. And so I mentioned that a few years ago, many of you may remember that Betelgeuse dipped suddenly in brightness, and it was noticeably dimmer, and it really changed the appearance of the constellation Orion in the sky, because Betelgeuse had dipped quite a bit. And you see that dip in magnitude right about the middle of the scale here a few years ago. So the other point here is that it's not a regular variation, so it's well known to have approximately a 400-day period, but there are other periods of variability superimposed on that. So there's quite a lot of stuff going on in this variable star, and so it's a reason why it's a target for ongoing photometry observations. So that's why I'm picking this one, to give you some idea of, or at least flavor for why we observe variable stars, because it's really interesting, and the benefit, in this case, of photometry. So this is, if I plot the same chart here, just a bit of self-promotion just to show that the observations that I've made are in orange crosses, so I plotted them here too. And you can do this if you go to the AAVSO website. You can plot any star if you want to plot a graph and see what's going on, and don't need to have membership in it to do that. It's one of the many options available to anybody who wants to look at it. So just a bit of self-promotion to show that my observations fortunately line up with many other people's observations. Otherwise, there'd be something wrong. I'd be doing something really wrong here. But it's an interesting case here of observe it whenever you can, and sometimes my observations are unique and they help fill in a light curve. Other times they correspond with many other people's when there's maybe good weather across North America for several days at a time or whatever, and there's good coverage of a certain part of the light curve. Anyway, a lot of details here. I won't go too far into that. I could give you some quick idea of the procedure of how to do photometry. And so it requires centering the target star in the reticle, and then flip the mirror out of the way, and then starlight focuses on the detector, and it shows up on the digital display, which we record that number that represents the output. There are some arithmetic transformations to do, and we end up with the magnitude of the star. And submit that to the AVSO, and that's the data point. And then after that, it's quite a lot of work, really, and it takes time, and after that, get some sleep. Okay, what else did I put in here? A few more details in case you're curious about the sequence. And so typically we do 3 observations of the variable star, and sandwiched or preceded and followed by a comparison star. So it's always reporting the magnitude of a variable star in comparison to a comparison. We call it a comparison. So after you do 3 of them, you see number 8 showing a check star, so that's a second comparison star. So do the check star also preceded and followed by the chosen selected comparison star. That's in case the comparison star turns out to be variable itself, which it occasionally does. So, or the check star might be variable as well. Anyway, some complications here, but that's a general sort of common sequence, and you can visualize it here by doing fill in this chart. That's basically what I do. Fill in this chart for each observation. There's 18 rows, and time each integration of 30 seconds, and then eventually get a mean. And that's how I take those numbers, and that's what we use. So in case you're curious, I wouldn't want to say too much about arithmetic. I'm sure you didn't come here to hear about it, but the light flux equation is based on a definition of stellar magnitudes. So it's based on the fact that 5 magnitudes difference is exactly 100 times difference in brightness, or light flux units. And light flux units is what the photometer measures. And so in that case, one magnitude is 1/5 the root of 100, or 2.512, or approximately 2.5. So end up with the equations at the bottom showing how to, especially the bottom one, difference in magnitude between the variable and comparison is given by this little equation, in case you're curious. So I just wanted to point that out, that that's sort of what's involved in taking the numbers off the photometer and converting them to a stellar magnitude. So I showed you, I picked up one example here to show you the actual spreadsheet that I use, and this is the star Deneb, which you may not have known as a variable star, because you'd probably say, well, that's a bright blue star and variable stars are red. Yes, but a lot of stars are pretty darn interesting when you start to actually measure them. Anyway, this shows you the on the left the 3 observations I mentioned, and the mean, and then the scale, mean divided by scale, the star minus the sky background, so logarithm, and eventually on the 3rd column from the right, you see the magnitude difference between comparison and variable. In this case, all 3 are 2.68, and so in this case, the standard deviation is 0.004. So precision of 0.004 magnitude is pretty darn good. And I didn't want to say too much. In fact, I took out the slide they put in about error analysis, standard deviation, because I'm 100% sure that 100% of you in the room didn't come here to hear about that. However, error analysis and signal-to-noise ratio is 100% of the importance of photometry, and paying attention to all the factors that affect it. So I'll just briefly mention it, but I didn't want to say too much about it. Speaking of Deneb, I think I put in a chart here. I did. I put in a light curve. So just you can see that over the past few years, we've been doing some measurements of Deneb. It varies between magnitude 1.23 and about 1.29 or so, and you couldn't really detect it by eye. So, but a photometer shows up these differences, and somebody started a campaign in the AVSO to have us start measuring this particular star, and so we did, and turned up some very interesting details. But still underway, study is still underway, but it's just one interesting example. I just picked that one because I showed you Betelgeuse earlier, which is also a very bright star. What are the target stars? Well, it's quite a list in the photometry program, and so I just picked off the first screenshot of the first page of the list here, and so they go from, let's see, the column underneath D and E is right ascension. So just the stars that are at right ascension 0 hours up to 1 hour are shown on this page. So you say about 24 times this is roughly the number of stars that could be studied by photometry. And one of them I recognize, TV Pisces, is one that I do fairly regularly, have been doing for decades. But anyway, just some of those stars, but even more important, the current photoelectric photometry program in the AVSO has a few selected targets, and these are the ones here that we're currently doing for the current season. And so ROCAST and the V509 casts have been studied for years, and it's really spectacularly amazing yellow hypergiant V509 cast, but wouldn't want to get too distracted on that. Mu Cephei is also a very interesting star that I've been measuring for decades, and it's also called Garnet's red star. So if you're not aware of it, you can see it. It's around 5th magnitude. See it in binoculars, if not by eye, and it's one of the reddest stars in the sky. So it's really neat to look at. Anyway, didn't want to get too distracted on any of these. Just wanted to show you that there are some stars that we're currently doing. We do each year and every season, depending on selected programs and campaigns. And speaking of campaigns, I think I threw one in here. Or here it is. A current campaign that's requesting photometry observations, Sigma Gem, in support of a couple of satellite programs. And I think at the bottom it says, or I put the asterisks by it. I just try to read it a little bit here. Photoelectric photometry observations are the most practical and most requested way to observe this because of the brightness, SIGGEM, and some other details related to how close comparison stars are and how bright it is and so on. So it's just one of the stars and just one example of a current campaign requesting photometry observations. So I thought I'd mention a few rules about photometry, also to give you some idea of how it's done and why it's a little bit of strict sort of hobby. Briefly mentioned that comparison stars need to be a similar color as the target and non-varying. So hopefully the chosen comparison stars are not varying, but sometimes they do turn out to be variable themselves. Even more crucial, we need clear sky, no clouds, steady sky brightness, steady transparency. And that means no moonlight nearby that's changing. Twilight can't be affecting it. We can't have changing cloud cover. It's got to be zero clouds. So there's very strict conditions where I do photometry. And so the cartoon I put in shows we've got to look through the eyepiece of the photometer to center the target in the reticle. And when I see the sky turning green and bright, uh-oh, turn around and look up, and there's a aurora blasting up. This has happened a few times. And okay, time to pack it up and fast forward to the bottom point I showed you in the slide earlier about the procedure, and that's go to sleep. And so there's also some other strict requirements about the color filter for the photometer and transformations for that filter to be transformed so that the observation from the photometer can be converted to a standard photometric system and be compared with other observations from other observatories around the world and spacecraft, all based on a similar photometric set of filters. Filter transformations, a bit of arithmetic involved in doing that too, and it takes some effort to do it. Fine, won't waste your time on that. I just briefly mentioned that there are errors to watch out for and try to minimize errors. And so, so I just try to give you some idea of what's involved in the hobby here by saying these are things to watch out for. One is due on the optics. So you may be familiar with, you're using a telescope with a corrector plate on the front or glass on the front end, might be a refractor, and you see things starting to get foggy and hazy, and you find out that your dew heater has stopped working, and maybe have a wonky wire connection and the plug is loose. Anybody ever seen that? Quite possibly. Anyway, that's one of the hassles to put up with, and keep an eye on it, and try not to let that happen. Watch out for setting up the wrong target or comparison star. Easy to do when there's, say, something like moonlight and you can't see all the faint stars that we normally rely on to choose the correct comparison star. Imperfect tracking. Yes, does your tracking motor ever suddenly stop or go wonky or start slowing down, and so that your target star doesn't stay in the reticle of the photometer? That sure does happen. Is it possible to make a mistake data reading? It sure is. Is it possible to make a mistake with recording the wrong date and time? It sure is. And watch out for darn really bad nuisance clouds when you think the sky is clear and then one little cloud appears. You say, where the heck did that come from? Or you didn't even see it, and then you see it right in your field of view. Say, hey, I thought the sky was clear. So we've got to watch out for that stuff. Satellites and aircraft, so normally I can see them coming. Okay, so often you can, but contrails are a real nuisance. So I mentioned the sky needs to be uniformly clear and dark or bright during the period of the observation, so that it doesn't vary from one observation to the next. Contrails are quite a bit of a nuisance. So are fireflies in the summertime. One of the worst of all is when you see a whole long line of satellites coming right toward your field of view and say, oh man, what's going on here? Maybe I should just take a break for a cup of tea. But it can take a few minutes for a whole long train of satellites to go by. So I'm blaming Starlink here, but it's worse than that now. There's now an Amazon constellation of satellites being launched, and I think there's a British one as well. Don't want to talk about it. I didn't want to talk about negative thoughts, so let's skip that. Get on to the next slide. Comparison stars, just to give you some idea. You may or may not be able to read the charts here, but just put in a couple of examples. The one on the left is for Betelgeuse, and you may not see it, but the chart that I use here, I just took an image of it. Betelgeuse is sort of near the upper left there. It's a fairly bright star, and you may not see the stars I've circled for check star and comparison star. They got to be, the telescope has to be navigated to them, and that's fine. I'm quite familiar with those fields of view. But the one on the right is for another star, and it's got some fainter stars, and if there's bright moonlight, I'm blasting brightness across the sky, and it's far harder to see those fainter stars, and it takes far more caution and care to get centered on the correct star. So there's some challenges involved here, and it adds extra complexity to the hobby, but it's fine. So I thought I'd set up here, show you that there can be quite a variation of great conditions for photometry from one year to the next. So some years I get away with a lot of observations, other years I get away with Looks like 20 minutes is up. The list for 2021 is a good dozen or more, and 2022 had a reasonable number too. For 2023, I've only got half a dozen so far, and they're all last winter. And so similar with visual observing, it was a bad year for smoke, because every time the sky cleared and wind came from north, it brought down smoke. And so I saw smoke getting in the way of doing reliable photometry right through end of September. So I just put in a chart at the bottom showing one example from May where you may remember that smoke is pretty darn thick. Thick smoke across the sky really messed up our views. So made it hard for doing anything like deep sky observing. And so for photometry, it was a total no-no, because it means sky transparency can vary during the 20 minutes. So it's a no-no, it's a bad year because of smoke. That was the point here. Anything else? Yes, just for going into the future, are there current campaigns going on? Yes. Are there going to be future campaigns requesting our observations? Very likely, yes, probably. So I just put in again this chart showing Betelgeuse because it's a non-regular star, and you'd say, what's the future for it? Well, we don't know, can't tell, because it's a very interesting, varying star, and it just invites for continuing observations. So this is just one example of reason to continue photometry into the future, to monitor this star and many others. So that's how I see the future. So I should also say, do I need to do photometry? There are online telescopes where you can pay money, and telescopes are set up somewhere in an observatory. You can get photometry of a star. So why waste my time when I can just go online and get some telescopes to do it automatically? There's also data mining that could be done. There's a huge amount of data and photometric observations of stars waiting for people to analyze, downloaded from satellites that are monitoring the sky constantly. And there are also numerous automated photometric sky surveys being built, and just about in, actually this one example I put here has been operating for a couple of years. Well, this one uses 8-inch Schmidt-Cassegrain telescopes pointed at the sky in a big, huge array. There's another set called, I didn't remember the name, but there's a small automatic telescope you can buy now. I forget its name. They're fairly common, they're fairly widespread because they're totally automatic, totally electronic, nothing to connect, but surveys are being set up with those too. But anyway, the point is, and there's also huge observatories about to come online, Vera Rubin and some other observatories that are going to do photometric sky surveys constantly every night. And it's considered that when this every scope, as one example, when this every scope at University of North Carolina becomes available to share its data, it'll mean the end of variable star observing. There'll be no more need for variable star observers to report to the AVSO because all the stars will be monitored by these automatic observatories. So it could end soon, maybe. However, if I ask myself, do I need to do photometry? My answer is yes, just continue. So this is the last slide. I'm going to continue doing photometry. Data continues to be valuable and useful. I find it to be fun and relaxing. And I thought I'd point out a few quotes from Dr. John Percy, who's been fortunate to have him as a great mentor in this program. He's been with this program for as long as I've been in it. He headed the photoelectric photometry program in the AVSO when I joined. And this is from the PEP Observer's Guide that I briefly showed or mentioned to you. Quotes from Dr. John Percy from years ago from somewhere else. So I'll just read several lines. Choose a program which fits your equipment, site, ability, and your time available. There are definite advantages to working with a group on an established program or campaign. And photometry should be enjoyable as well as satisfying. And so all these apply to me when I think and when I reflect, like no pun intended, but when I reflect on the past few decades since I've been doing this, these lines that John Percy wrote years ago all apply to what I've been doing. So I find it fun and relaxing. And so for that reason, I'll be continuing. So I was going to say, I could say, it might be tempting to say that this has been a great journey, but it's better to say this is a good journey, ongoing, fun journey that I'm enjoying. Anyway, that's my last slide, so I'll finish here, and thank you for your time.
Thank you very much, Frank, for sharing your journey and continuing journey with us. Do we have any questions in the room? One?
Hey Frank, excellent talk. I'm wondering if you could show your first slide of Betelgeuse observations with optical and photometric. So there's a gap in the optical that the photometric observations continue through. Is that full moon or some other reason?
It's an interesting thing that's come available. A guy started a couple of years ago. First of all, there's a gap in every variable star observation where it's near the sun and people can't observe it. Furthermore, it's worthwhile. Photometry can't handle those tight periods when it's in twilight close to the sun, but visual observers can. In this case, I didn't want to point out that, but it's a good question because a guy started doing showing that photometry of Betelgeuse could be accomplished using GOES weather satellites. So he showed an image of the Earth from geostationary satellites showing all its weather patterns and so on, but showing Betelgeuse in the background and enough stars that he claimed that he could do photometry. So he perfected that. So he's been doing good high precision observations using those satellite images of the Earth with Betelgeuse in the background. So that's where the gap gets filled in past year or two.
So Betelgeuse is photobombing the Earth in the photo, in the picture. Okay.
So it's an interesting question, but it's a very interesting technique this guy has been
Yeah.
developing.
Now in your further slide where you showed your observations along with the other ones, yeah. So are yours biased a little brighter than the others, or do you think it's sort of a mix?
Well, it's tricky because you see in some cases they line up perfectly, but you see in any particular case, such as where the arrow points to, you see it's tricky there because you see at that particular date and time where my observations are, there's quite a range, although the precision should be 0.01 magnitude for observations submitted to the database. There's quite a variation there. There's the variation of I wouldn't say a whole tenth of magnitude, but I would say, let's say maybe 0.05 magnitude, just from one point in time, just from a whole bunch of observers whose precision ought to be 0.01 magnitude or better. So short answer, why that is, I'm not sure, I don't know. But that's partly the benefit of combining a lot of observations together. Which one is right, which one is wrong? Nobody will ever know, because there's whose basis is correct.
Right. Thank you.
I've got I guess a technical question and a more general question. The technical question is, what's the field of that photometer? Because you'll have background stars of various brightness. How does the system deal with that?
So the way I deal with that is that the focal length of the telescope determines, because it's a fixed reticle on the photometer, so the focal length of the telescope determines what exactly that field of view is. And I'm not sure, I can't give you a number in seconds of arc, but it's some fixed number of seconds of arc. And I've used different different telescopes in the past. I've used my 10-inch reflector, 6-inch reflector, and I'm about to switch from the 8-inch reflector I showed you to another 8-inch reflector, and I might set up to use my 11-inch SCT, which is currently for sale, but if I don't sell it, I might set it up to use it for photometry, and it'll have an even tighter field of view. So the problem is that sometimes some of the stars on the program are too tight. They're close to a double star. And so I can't really do them. I can't really separate the star by keeping the target star in the middle of the reticle and keeping out a nearby neighboring star, which is bright enough to contribute some brightness. Can't do it. So people with a longer focal length and a smaller field of view can do it. And so I could do it too by inserting a Barlow, or sometimes a Fabry lens gives a wider field of view, but I could insert more lenses, but that would mess up and require me to do another transformation observation, because the transformation would mess up, because the whole set of light passing through the glass will change a little bit. Anyways, it's a complicated set of answers related to transformation. But the point is that yes, there are some stars that are too close together so that some will be in the field of view and contribute light, and I just say, okay, can't do it, don't do it. Most of them, the ones that I've chosen, all work out because You can see the target star, such as Betelgeuse, and there aren't any background stars within that field of view bright enough to affect it. So it's, of course, there are some fainter ones, yes. You could always say that there are some fainter, if you look to 12th, 14th, or 18th magnitude, they would be there. But they're all stars that I've chosen that my system can handle to avoid that problem.
Okay, and I guess the more general question, and you may have alluded to it already, or an answer to it, is looking at that data between the visual and the photometric for Betelgeuse. It's like, why would people do visual when obviously the photometric is so much more precise? So what's the value in people actually just continuing to do visual, other than saving a whole bunch of money on equipment?
My answer is there's not really much value. The reason I've seen CDA VSO promotes visual observing of variable stars as one of its training programs or ways of interesting beginners, motivating beginners to get involved. So they have a list of 10 stars. Not even sure if Betelgeuse is one of them, but there's occasionally been some excitement to they or others try to generate about, wow, get an observation of Betelgeuse, compare it, look at it, it's changing brightness. It's a great target to observe visually. And maybe you can. Maybe you can. There have been people who've been doing this for decades, and they don't seem to be too bothered by the fact that, to put it one way, it's sort of a waste of time when there's so many photometric observations that are more useful. However, I think it's not a waste of time because it motivates some people to find it fun to look at. Maybe school children or first-time sky gazers can get excited about it and say, hey, you can make an observation of this variable star. You can actually see it changing because you can see it, by change maybe half magnitude. A lot of people can detect that quite well. Say, hey, this is interesting, and get excited about it. And because I know years ago that there was some noise about the too many of the beginner stars were in Orion, because Orion was chosen as a great constellation to watch numerous variable stars in it that were ideal for beginners. So too many people, beginners, possibly school programs or whatever, were focusing on Orion and all getting a huge swamp of data for several variable stars in Orion. So I think it has visual appeal, maybe some excitement about it that motivates people to look at the sky. So it's been promoted, I think, for basically that sort of reason. So that's my best answer to your question.
Any other questions over here? Let me go because I think, yeah, for a while.
Is your equipment powerful enough to spot transiting exoplanets?
Interesting question because basically no. The answer to that is that that's normally done with so-called CCD photometry, where I can get away with a much tighter, smaller field of view. The longer answer is that if I'm considering setting up my C11, 11 instrument cassegrain, because it could do it, it could handle that. It could handle much fainter stuff. It could handle some stuff like photometry of Jupiter's Galilean satellites, spots and feature markings on Mars, and some other planetary projects that I think would be pretty interesting. So with that telescope, or a powerful enough telescope, more than what I'm using now, yes. Currently, right now, no. I'm extremely busy just with variable stars.
Thank you.
Hi, I've got a question for you and a couple comments, if I may.
Sure, go ahead.
My question is your photometer a self-contained device, or do you need to plug it into a computer?
Interesting question, because I avoided mentioning that. Self-contained device that has a digital readout. It does have a plug for computer output. So I've chosen, the way I do it, I tried to keep the answer concise. I do it by writing down the numbers on a pad and then typing them into the spreadsheet. The longer answer is yes, it is capable of outputting through a plug made for that purpose into software. And I actually did that years ago, decades ago, I started to do that. And the reason I stopped, and actually Optech, the manufacturer of that photometer, makes software and the hardware for interfacing. And in fact, I'm as far as I can tell, in the current AAVSO photoelectric photometry program of several dozen observers, I'm about the only one who does it manually. And it's because I found that, I showed you in the last slide, I claimed it's fun and relaxing. But the way it can become not fun, not relaxing, is to start arguing with cables that have wonky connections and don't connect perfectly, and get a whole set of observations. It seems to be going great, downloading into the computer, and then why is it suddenly stopped? Then I got to trace back, why is the cable loose, or why is the wire not connecting? Why is something in the laptop not recognizing something all of a sudden? So it can be instead of being fun, it can be pretty darn aggravating when I do it through the cables into the laptop. And so I've decided it's way faster, way more fun just to do it manually. So that, hopefully that sort of answers the question that, yes, it can be done electronically.
Do you mind if I offer a couple of comments?
Nope, glad to hear him.
Okay, for visual observing, the AAVSO does have what they call the legacy observing program, where they're inviting people to observe a limited number of stars visually so that they have a continuous series of observations done the same style going back 100 years or so. So there is still some value for visual observing. The other comment I was going to make is, while the sky surveys are making an awful lot of variable star observing obsolete, I think it's still going to be viable for things that change rapidly, cataclysmic variables, things like that, where the changes are happening faster than the sky surveys are keeping up to, most of which are collecting between 1 to 4 observations a night. So I think we still have some work ahead of us in the future.
Yep, I agree 100%. So I'll comment on those comments. And first one was about legacy objects. And so one complication with the automated sky surveys is that a value of ongoing visual observations is that they'll form what's the word? A background basis for comparison. So in case the photometric sky surveys appear too wonky or change too much, there'll be a good solid background for continuing visual observations of those legacy stars. Exact same thing applies in solar sunspot observing. The record has gone back several hundred years by visual observers, and continuing visual observation forms a good basis, or there's a better word I can't think of offhand, for comparison of the current satellite measurements, which can do it automatically. And so the visual observers will always have some value, yes, especially for particular stars, for sure. And so you mentioned, another comment is about the dwarf novae is one example. I have to say that it's plain fun. It's really exciting to look at a dwarf nova, such as one of my favorites being SS Cygni, among others. You look at them once in a while, and all of a sudden, one day you look at it, it's blasted into outburst. And that's really fun. That's really neat to see. It's just amazing to see. So that justifies continuing to do it, even just for fun. Even if the visual observations are obsolete, because the automated photometry servers can do a better job. It's still fun to watch them. It's really fun. It'll be enjoyable hobby for the rest of my life whenever I can continue, as long as I have the ability to continue physical visual observing. So it'll be fun. So it continues to be fun. It will be fun. The other value for visual observations is during twilight, which you briefly alluded to, that when the photometric sky surveys can't handle it. They can't go too close to the sun, but visual observers can. They can look in morning twilight or evening twilight, catch their favorite variable star. Maybe it's an outburst, maybe it's got some variation, which the photometric sky surveys can't do because they're programmed to not go too close to the sun. So yes, you're correct. There are some ongoing values for visual observing, despite it becoming mostly obsolete by programs coming online. But yes, good comments, I agree.
All right, we have a question over here.
Is it known why the magnitude of Betelgeuse dipped?
Yes, the reason why the magnitude of Betelgeuse dipped was because of a cloud of dust. Cloud of dust got emitted from it, so it's fairly well, a bit of more background. It's well known that red giants, supergiants are sooty, create some dust, some molecules. And in this case, it's been decided that by a lot of other observations and combined with the visual observations, that a huge cloud of soot got emitted from the star and blasted out into space and obstructed part of the star. So I think it's pretty neat. It's quite amazing. There's a lot more details to it than that. But basically, that's what happened. That's the reason why.
Thank you. Anything online?
We have one question from Zepfan, and he asks if Frank has tried exoplanet detection. I'm thinking if that's already been answered, if you can elaborate on that at all, or mention of any other observing programs that you know of for exoplanets, specifically in the AAVSO or any other astronomy organization.
Yes, so the short answer is no, I'm not involved in it. Longer answer is yes, the AAVSO has an exoplanet section where there are a lot of observers, a very good training program, a manual anybody can download for free, outlining which equipment to use, and basically CCD or CMOS detector cameras are being used to do very good work on exoplanet detection and measurements. So longer answer is yes. I haven't got involved in it just because of time and resources, and I can be busy full-time just with my own little programs. But there's NDA-AVSO, there's loads of other programs that people would find interesting, from spectroscopy to solar to all sorts of eclipsing binaries is one form of variable star, and many others besides eclipsing binaries, besides exoplanets. So there's a fully developed program there with instruction and courses for how to do it and proper practices for doing it. And I'm just not involved in it, partly because of time.
Frank, I have a question myself. Have photoelectric photometers been displaced by CCD cameras?
Yes, yeah, the answer is for sure. They're displaced. It's probably 20 years ago or more. People were stopping doing photoelectric photometry. I actually stopped too. I actually got a CCD camera, and I was going to start into the CCD photometry because I was convinced. I go to the AVSO meetings and see that most people are doing CCD photometry, and why are these old dinosaurs still doing photoelectric photometry? And so, yes, it's replaced a lot of photometry, and it's easy. It's automatically done. People program their gear and observatories to do CCD photometry, or it's CMOS camera based now, but let's just generally refer to it as CCD photometry because that's how it began. When CCD cameras became widespread and well known on how to use them a good 20 years ago or so. And I still have the STT4 camera I got, but however, it was this case of, for me personally, it was this case of needing connection to the laptop computer, saying, why is it causing hassles in the cold and cold weather and conditions where it's not looking, and so I got pretty darn aggravated, spending a lot of time under the stars, trying to troubleshoot things, trying to make things work. Whereas I found that by continuing to do photoelectric photometry, it was really easy, it was just a breeze, partly because I was already familiar with it. I knew how to do it, and by doing it manually, without connecting through any wires or work to the laptop, it was too easy. Whereas the CCD photometry for me was pretty darn aggravating. And so, yes, a lot of people did switch to CCD photometry. There's one other reason I should mention, and that is because I didn't show any examples. I just very briefly mentioned error analysis. But I could show you a lot of light curves that people complain about on the AVSO website for any particular star where there's some precise observations that line up really well with whatever they consider to be reasonable, and there are a lot of outliers were done by a photometer that are way off, and so that's because people do it automatically. They have their photometer, their CCD photometry gear running all night while they're sleeping, download stuff, it does all the analysis automatically, and it shoots it off to the database automatically without people even looking at it, saying, is there anything wrong here? Were there any clouds? Was there any aurora? Was there a contrail? Did any satellite shoot through? Nobody knows. Nobody cares. Or a lot of people don't care. So it's been one problem. One of the complications for the AVSO has been quality, data quality. They've been arguing with that for the past several years. They have a committee to try to deal with it. But it has been a big question about, especially with automated photometry. It can be done so easily and so efficiently that a lot of bad data end up in the database, and it's caused by the CCD photometers and their gear and their observations that people figure or assume is a great night's work. The observatory did quite a lot of work, and it shot all the data off to the database by itself in the morning, and Sounds lovely. However, when you plot the light curve, say there's something wrong here, but we don't know. So there are a lot of complications with it. Whereas for me, manually doing photoelectric photometry, it's fun, easy, and I can decide when something doesn't work, data isn't quite right, there are some problems, throw it out, stop doing it, go to sleep, that data isn't right, don't submit it. So I find that fun and interesting. So that's a general answer.
Very good. So let's stop here. Thank you very much again, Frank. Very interesting presentation. We'll go to fun facts so we can switch over to our next speakers. All right, we're back. Our next speakers are Chris Vaughn and Tony Horvatin. They'll share the memories of Blake and Carol with us.
Thank you for having us. We're just going to dip a toe in the water of what was Blake Dancaro, where he was such a diverse guy. It was hard to do it all in 20 minutes. So let's just get started and tell you a little bit about him. Oops, is that the beginning? No. There we go. Like that. There we go. So I'm going to talk about Blake as an astronomer to begin with. He was an astronomer in every sense of the word. I mean, he was a modern-day Da Vinci or Galileo, if you want to think of it that way. He loved viewing celestial objects through a manual telescope or through a fancy go-through system. And, he appreciated the deep sky objects that we all love, the Messier objects and things like that. But his true passion was double stars, and he really liked to look at double stars because he could do that when the stupid moon was around, which is something that he used to talk about a lot. Now, for Blake, it was really the physics and the mechanics of the double stars that appealed to him. I mean, he was, as I said, a real scientist at heart. So in around 1991, he began logging his observations of doubles, challenging himself to log as many as he possibly could. And he trained himself, and anybody who had some interest as well, he would preach the gospel to them on how to measure their motions, their brightness, log their characteristics very, very precisely and accurately, and therefore submit his data for research. So he participated in that to a great extent. He loved to split the Struves, as you might say, challenging himself to split the more difficult double stars, attempting with different telescope and optic combinations and different sky conditions. So by the time he got to the end of his life and the point where he could no longer do it, he'd reached something like 1,850 double stars in the catalog, which is quite an achievement. That work will live on because Blake honored us by creating the RASC double star observing program, and Frank Dempsey and I have had the privilege of being among the first to do that program, and it's kind of fun to do those programs while proud Papa Blake kind of monitored our progress and delivered our certificates and our pins. Now, Blake was, as I said, a superb observer. He was a master of the techniques for planning and carrying out observing campaigns. Especially, he liked, one of his favorite apps was Sky Tools. And if you knew Blake, you knew that he was always on about Sky Tools and how accurate it was to replicate the view through your telescope with your optical train. He always made an effort, though, to share his expertise and advice. And he would set aside his plans for the night. I mean, if he came across somebody that was struggling and needed help with their setup, or where, you know, having difficulty finding an object or noting what to see or what to find about it, he'd set his stuff aside and he would devote the rest of his night to helping that person. And so there are countless stories of people who have reminiscence of Blake, you know, rescuing them, saving them, getting them started, getting them going. And, you know, lots of us are better observers for knowing Blake. Now, in 2022, I think by then he was already ill. I'm not sure the stage of it at that point, but he became the first astronomer in residence at the Killarney Provincial Park, which was an initiative of York University. And because of his talent, his super talent for organizing and documentation and everything, he was the perfect person to start it off, because he got up there, he'd get everything organized, he was able to do outreach, he was able to do astrophotography and teaching the park guests about everything, but also setting things up so that everybody that followed along behind him could be successful in the role. Now, that's the nights that are clear. On the cloudy nights, he kept busy as well. He turned his attention to making the Rask Observer's Handbook the most effective and accurate volume that it could be. Always, you know, finding bugs and things like that, and making sure that the editors knew of little tweaks that needed to be repaired. Then he decided that he would like to teach rascals how to use Stellarium, recognizing it was one of the most effective tools and accessible tools that we all have. I use it all the time as well. And so he created the Stellarium training course, and then later he began working on or delivering a backyard EOS training course as well. And what's great is that he produced a team of people that can carry the work forward and continue on. Blake took on the role of the observing chair of Rask National, which allowed him to improve their process, improve the online resources. So if you go to the, let's just look through some of the slides here. He was a maker as well. Here's some pictures of his proud moments at Killarney Provincial Park. That's the supernova in M101 there on the left that Andy mentioned. Here's his life list of his double stars. You can see that row 959, and this is just half the alphabet. So that's how many he had. Very meticulous records. And then here's the link to the page to the Rask Observing Program. And the Stellarium as well. Now, Blake loved technology, so he was a big proponent of the robotic telescope at the Burke-Gaffney Robotic Observatory at St. Mary's University. He inspired lots of us to use that free service. He got me to give it a try too. I was a bit intimidated at first, but he walked me through it and showed me how easy it was. And what's great is that he has, I'll mention his blog in a couple of minutes here, but he actually made an effort of taking images of all of the double stars that he was interested in and many deep sky objects, and archived those in galleries on his website. And here you can see on the right-hand side of the screen, just a little snapshot, subset of some of Blake's photos taken with the Burke-Gaffney telescope. So he would request the images, and then he would process the images and then post them on his site. So Blake delivered countless presentations, both in person and online, on double stars, on DIY, on making things. He delivered The Sky This Month at lots of the Rask meetings, and much, much more. And what's funny is that YouTube constantly offers his barn door tracker video to me when I'm on YouTube. So he did something right there. So finally, just a final mention is that, you know, in another gesture of his selflessness and his generosity of spirit, you know, Blake bequeathed his telescopes to the Rask Toronto Centre so that others can follow in his footsteps. So I'm going to switch it over to Tony here so you can talk about another dimension of Blake.
Okay, thanks very much, Chris. So yes, my name is Tony Horvatin, and I'm very proud to be able to stand here tonight and tell a little bit about my experience of Blake within the Toronto Centre. But before I get into that, I would like to mention just that the fun facts presentation that we all see between these presentations was in fact designed and built by Blake. And it's quite obvious when you look at the jargon and the language in it that is very fun and very informal. And that was Blake. So enjoy that presentation when you see it. So, well, I'm going to speak first now about my experience of Blake at the CAO. And Chris and I are going to switch off a little bit there as we go. So at the CAO, well, where to begin? Well, in my capacity as the maintenance team lead at CAO, Blake was a model of what you could ask for in a volunteer, and someone who would come forward and be able to offer their skills, their time, and their talents. He was skilled in so many different valuable ways. Just physically, he was an IT. He was skilled in IT. He was a computer trainer. In IT, he was both able to deal with LAN infrastructure as well as software. So he took care of all of that business for us. And we have a rather large LAN on the site, so that was important. He was an experienced builder in construction as well. And he was savvy with working with small engines as well. So, pardon me. Aside from all of that, he was prolific in writing SOPs and manuals. And that was something, is always really one of those drudgery things. Well, committee needs to have manuals and what have you. But he just dove right in. And I'll show you a few examples as we go as to what he was doing there. So, but at the site, in 2007, when he joined, he just dove right in and became a volunteer, and in lots of different portfolios across the center. But at the car, he became pretty well indispensable in honing all of our procedures and documenting all manner of things and tightening up our protocols and record keeping. So at work parties, as you can see, he just dove in and just got down and dirty. No task was beneath Blake, what needed to be done. And he was often seen on the job with his familiar yellow helmet and what he called his safety sandals. So, yes, quite. And anyway, so here's a couple more shots to enjoy. Blake had a lot of facial expressions, and I particularly like the one of him riding the mower here, which is in part disassembled as it's under repair. But he was just such a joy to be around. He was very infectious, and as a mentor and a motivator, he was very good at that. We've undertaken a lot of major projects at the car with simply just volunteer help. And yes, that's Blake climbing on the roof of our garage as we're trying to put up the Davis Weather Station sending unit. And to the right, you've got a picture there of, this is just the end of we actually have a wheelchair accessibility ramp that goes up to our front deck that we had a contractor build the infrastructure for, but then we did all the picketing and all of the board laying as a team. And this is the ceremonial laying of the last plank in the deck there. And Blake was right in there to make these things happen. And we've done a lot of many heavy-duty kind of projects in development of the sites simply with our volunteer labor. And members like Blake and Jeff Brown, who we've mentioned before, were really kind of instrumental in sparking the fire and building community in our volunteer members. So we mentioned a little bit about record keeping. Well, here's a good example. This is just the first page of a 3-page spreadsheet that he created that documents what different documents are, what they do, where they're kept, when they're updated, what have you, and it is letter perfect, I assure you. And he just dove into that. So the picture on the right is cool because it's a face I've often seen from him when he's diving into documentation. It reminds me of his favorite answer when you ask him a question. It's RTFM, so that was Blake. So here's another couple good examples. On the left is a CAO timeline that he drew in Visio. And believe it or not, it is very detailed. Even though he became a member in 2007, he went back in the records and journals and created this graphical timeline of when everything occurred since we got the site in December of '97. And he was that meticulous. And the document on the right is just an excerpt from a maintenance log for I believe it is, in this case, it's the generator. It's our standby generator, the Guardian Generac that we have. And as you can see, just the attention to detail was just amazing. And I doubt that we'll be able to continue that at this point. So at CAO, Blake also regaled in our outreach efforts. And I haven't put any pictures in this segment. I'll leave that up to Chris when he comes back to that as well. But he enjoyed many, many member social events that we had there, such as open house and awards picnics, our public events that we did for the public there, and the group events that we held. He also, I believe, served at some of the scout camps that we had there. So there were many facets to what Blake was doing at our site. And I'm very glad that he reported on many of these activities at RAN member night presentations. And these, of course, are all archived now on our YouTube channel. So they're there for posterity, for people to have a look and go back and have a look, and a little bit more on that later. But at this point, I'm going to turn it back over to Chris.
Thanks, Tony. One of the things that neither Tony nor I included much of in this presentation tonight is all the accolades and awards that Blake got. So that could be another presentation of itself. You can see one example of that here, though, in the upper right, where he was part of the essential team at the DDO that made it a success after we returned. So Blake had always been a participant since he was a member of the Toronto Centre Family Nights and Speaker Nights at the DDO. In that period up to about 2016, he'd bring a lawn scope or he'd fill a volunteer role all the time. He would deliver talks at the member nights we held there. In 2013, he organized, you can see in the lower right corner there, a Telescopes for New Users workshop. It was spectacular. It was amazing, and he was like sergeant at arms, you know, directing all the participants, both the subject matter experts and the guests as well. And one of the unique things I remember is that he actually made stickers of every sort of telescope type and make and manufacture, and we would wear whatever sticker was relevant to the kind of telescope gear we were an expert in. So someone could look at our chest and say, oh, you know mead, so I'll talk to you. It was really, really well organized. At some of the Toronto Centre awards banquets or awards barbecues that we held at DDO, I remember one time, at least on one occasion, that Blake happily researched the DDO and led everyone on a merry tour around the grounds, just for both for the RASC's members, but as well for the spouses and other plus ones that came to the event. Now, there was a pause at DDO for a while, and when RASC Toronto Centre returned to the center in a few years, basically in the early 2010s or 20s, Blake stepped right up and became one of the trainees of the big telescope. So we were short of people that could operate the telescope at that time, so Blake was one of the people that stepped up. Now, being such an accomplished astronomer, outreach expert, technical wizard, he became soon one of the, a few really prime operators of the big telescope, which allowed us to deliver dome tours, let him lead dome tours and operate that historical telescope. He volunteered at the big DDO opening kickoff. I'll show you a picture of that in a minute. But he also served alcohol at the RASC Night with the Stars event. That's the slide on the right, on the left-hand side there. So he had a server's license, and he chipped right in. So everywhere, he was everywhere. So there's a couple of shots of Blake at the DDO. And that's Tony DeSantos. He was able to bring Tony into the dome for a look around at one point. So he also served as a subject matter expert when we did some live stream events from the DDO, including our Mars Madness stream. And like any of us that have fixated on the stars, all our lives, Blake was super chuffed to use the giant 74-inch telescope. I mean, he delighted when he got to use it for outreach, and he would also spend some time taking some peeks at some of his favorite double stars through it. And he and I would love to geek out about the technology of the day and the mysterious antique eyepiece that we were using for outreach, and what was the focal length, and what was the magnification, and what field of view did it give us. So he would simulate it in Stellarium or in Sky Tools, and we would try to sort of sleuth around what was going on. And all of that was helpful because eventually Richmond Hill, went ahead and purchased a modern eyepiece to use for outreach at DDO, and I made sure I consulted Blake when I was assisting Richmond Hill with selecting the eyepiece that we picked. Putting on his documentation writer's hat, though, Blake helped us compile a lengthy manual for telescope operations at the DDO. So we left out no detail. He made sure that there was no detail left out, that he had photographs of everything. He even sketched the reticles on the setting circles so that we could explain what every little tick meant, so the operators that were learning to use the telescope would have everything that they needed to do. He also took it upon himself to build a replica 3D print model of the DDO scope, and he had assistance in that from Ward LeGros and Steve McKinney. And what's nice is that these files are still available, and if Rascals want to print their own DDO replica, they can do that. We can get them a copy of those files. The DDO committee sorely missed Blake when he moved away from town. He still managed to help us out, though. He actually took there's a 10-inch Dobsonian at the DDO, one of the outreach scopes we use there. He took it home and he fixed it for us. And my first clue that Blake was ill was I had made arrangements to go and pick up that telescope from him a couple of summers ago, and that's when I could see that something wasn't quite right. He shared with me since then many times that he missed being at DDO and running the big scope, but his last visit to DDO was not that long ago, before the end, and that he got to take Greg Crinklaw, who was the author of SkyTools, his beloved SkyTools software, on a tour through the dome. So that was a great treat for him to do as well. So I'll pass over to Tony.
All right. Thanks very much, Chris. So as you can see, the titles we picked here are a little bit cheeky, I guess. But so in terms of thinking of Blake off the clock, that is, so not official duties for the Toronto Centre or the RASC, because he did pull yeoman duty for both organizations. They are separate organizations with different programs. He really enjoyed the social aspect of meeting together with the friends he'd made at the Toronto Centre. So both of these pictures are taken at the annual Algonquin Adventure, which was run for many years by the Chapmans at the Mew Lake Campground in Algonquin Park. There was a bit of a hiatus, but now Toronto Centre has brought that back, the September Adventure. At this point here, I'll just give a little bit of context to what you're seeing. So the slide on the left, that happens to be at our yurt at the time when we were there. And our son is cooking up some back bacon, and a number of other campers are quite fixated with the smells of the cooking bacon here, and as is Blake, who was very fond of the barbecue. So lots of good times to be had, not necessarily in astronomy. On the right, this is a birthday cake that Blake had because it was just around his birthday time, and his friends had got together and prepared a birthday cake in advance for him. Also, the Algonquin Adventure on the left. Here, Blake is very proudly receiving his Moose, which is the 5-year award for attending 5 years of the AAA. And on the right is a trip to the Algonquin Radio Observatory, which is in the northeastern end of Algonquin Park. And there were a couple years where Toronto Centre members made a pilgrimage out to the ARO, which is still operating under private hands, or at least it was a couple of years ago. I'm not sure today anymore. And these were very fun trips, much like the social aspects that we ran in, that we encountered at the car and elsewhere. So Blake really enjoyed doing these as well. So this particular one, this was a rather simple trip. This was to South Etobicoke. There was a predicted ISS transit across the full moon, and back in the day, that was something to be able to go out, photograph it, record it, and we had our intrepid group. We went out there at something like, I don't know, 3 in the morning, or something crazy. It was freezing cold. And there's Blake with his portable setup there. He's all ready to video record it, and he did get a video recording of it. I don't know the date, but I'm guessing it's around 2010, I'm guessing, maybe 2012, not sure. So these kinds of things Blake saw as a great challenge. And it was, even though it was darn cold, it was a fantastic night. And we all then repaired to the Tim Hortons for warming up afterwards. So here we see Blake at the NEAF show in the US. And on the right, this is the group of intrepid astronomers from Toronto Centre that went to Wyoming, to Glendale, Wyoming, to view the total solar eclipse in August of 2017. And that was a fantastic trip. You know, it probably marks the high point on many astronomical careers of the people who went there. So here again, now on the left, we have a slide of the group that attended to the CAO to watch the transit of Venus. And does anyone remember the year? Is that 2013? Is that when that was? 2012, sorry? Anyway, what's interesting here is there's a group from Toronto, but there also is a contingent from the Centre Francophone de Montréal. They actually drove all the way from Montreal to find clear skies, so they came to our oasis at the CAO, which interestingly enough was quite cloudy when they arrived, and they were quite concerned about having driven all that distance, but in the morning it miraculously cleared the blue skies, and everyone was very pleased with that.
Tony, that's 2004, not 2012.
2004, wow, okay, that's going back then quite a bit. But it was a very comfortable venue. We had all of the equipment there. We had a very hospitable 3-bedroom residence. So it was a great venue to be able to host those intrepid travelers from Quebec. And on the right, also at the CAO, this is believe it or not, in the wintertime, you can get some good drifts of snow that are suitable for cutting with a wood saw. And we actually built a real igloo that you could seat about 6 or 7 people in. And this was February, and Blake is smiling away from the igloo that he helped create. And of course, some other activities. We see some fellow rascals with Blake attending the ball game here. And with that, I will turn it back over to Chris. Thank you very much.
So we really want to highlight the legacy of Blake's writing experience. You know, lots of us have seen his presentations in person or online, but not everybody may be aware that Blake had a blog called Lumpy Darkness. And he was a fine writer. He started the blog, I think the first entry is in 1970, way back when, and it built from there. And it was kind of a running log of his astro life. And he sometimes penned a little personal update, but sometimes it was a remark on a discovery or a space mission, or the new handbook came, or something like that. But it could also be a long-form analysis of some research project that he was doing on a telescope or on a piece of software. So it's a real gem to kind of dive in. And I'm trying to, a number of us are trying to make an effort to make sure that this doesn't go away, that this website gets maintained in some way and continues on. I already mentioned the fact that there was life lists posted there and galleries of photographs and all kinds of things. He wrote extensively on Lumpy Darkness about using a stellarium to control a telescope mount. He even asked the developers of Stellarium to make improvements that he noted were deficient in the software, which they did after his passing, unfortunately. The version where they kind of solved it came out in the last little while. So I mentioned the life lists and galleries as well. So there's the rest of the website, blog.lumpydarkness.com. So if you make a remark and dive in. And that's just a random page where he created an almanac for June 2023. I mean, just prolific, just amazing material there. As I mentioned, and Tony and I mentioned as well, he was a prolific author of manuals, including the DDO manual, CAO documentation, the material at the RAS National Observing Programs, and you can always count on that material being accurate and comprehensive. At one point, a funny story, in his role as the observing chair of RAS National, he discovered that David Levy had been updating his deep sky gem list in the Observer's Handbook from time to time. And that's fine, except that that's an observing program that people are trying to complete, and it might take 2 or 3 years to complete the program. So it's kind of a moving target. So Blake said, thanks, Dave, but could we just lock it in? And maybe if you want to highlight some bonus objects, something like that, that'd be fine. But please freeze the list so that everybody can finish the certificate and get their pins. Blake wrote a long-standing regular column in the RAS Journal called Binary Universe, as you can see there on the left. And it's another amazing resource if you want to go back to the back issues and read up on all kinds of useful astronomy apps and software that a lot of us can take advantage of. In recent years, Blake joined the team at Sky News, being able to contribute. Now, I think Blake saw a niche for himself because he was passionate about do-it-yourself and making and things like that. So a lot of his contributions to Sky News were in that vein. So there were articles on, again, 3D printing and do-it-yourself rigs and things like that. He was in discussions with the magazine about starting a new series on showcasing Canadian manufacturers of equipment, people like Kendrick and Norm Fulham and people like that. But sadly, both Blake and Sky News met their demise, prematurely, which is sad. So with that, I think we'll wrap up. And I just, Tony and I were going back and forth a little bit on some of our thoughts about Blake. And I think Blake would get a kick out of the idea that he was a multi-dimensional being, right? So a lot of us dealt with Blake in different capacities and in different roles. And I think that he'd have a kick out of that sort of moniker. It could be astronomy, it could be beer, it could be cars, it could be science fiction or some form of technology, anything you want. We can't think of a better example of a perfect rascal than Blake. He lived and breathed the mandate of RASC, spreading the joy of astronomy, mentoring people, helping them along. He set the bar high, but all we can do is sort of carry on from his example and try to emulate his good deeds. I'll recommend that if you haven't already seen them, after his passing was posted on the RASC National and Toronto Centre fora, that the posts were floods with memorials and remembrances and tributes to Blake. So it's actually a great, fun thing to read through and just have a chuckle now and again for some funny stories, but also just, reflect on all the great experiences that we all had with him. So I think, Tony, you want to talk about next summer?
Yeah, so I just wanted to mention, Chris and I had quite a bit of difficulty actually settling and deciding on what we wanted to say tonight, because where do you draw the line? I mean, there's just so much. The awards that he got, the 3 or 4 Toronto Centre awards, he got the National Service Award. But next summer in June, there's planned a celebration of life for Blake, and that will likely be at the CAO at the request of the family. But just keep watching the channels, the forum, and what have you for information on when that might be happening. And that would be a good opportunity for everyone to participate and either share their experience of Blake and to participate. And with that, I guess we'll take any comments or questions then. Thank you.
All right, so thank you very much, Tony and Chris, for taking the time to compile this list of memories, I suppose. Truly a remarkable individual and greatly missed. Any questions or comments, more than questions perhaps, thoughts, memories of your own you want to share for a moment with us? Nothing in the room? Online?
We do have a bunch of comments online and a question. Let me start with the comments first, if I may. So Pat Sellis wrote, Blake was an amazing resource, one of the best instructors I've come across. Louis Rifkin says, Blake was an amazing and always helpful and knowledgeable. Kim Hayes is asking, is there any way Blake's observing notes can be put online for observing? So that would be our first question.
That's something we can investigate, because we're in communication with this family, And all of that material is been recovered anyway, so that we can look into that, sure.
And I want to note that I just did a search on archive.org and have noticed that Lumpy Darkness has been added to the archive.org and has been updated recently. So at
Excellent.
least that part of the website will be preserved.
Excellent.
Eric Briggs writes, I am a big fan of timelines. I've got a pretty effective archive in finding aid to RASC history. Blake's skill at documentation is far more effective than mine. Pat Sellis, I've already read that, I apologize. Eric then writes, I definitely would like to 3D print Blake's model of the DDO. I'd like to put it next to the Hubble and Webb telescope 3D printed models that are on display at the RASC office. And Eric then writes, the space station transiting the moon event Tony mentioned was on December 10th, 2011.
Okay.
It was a trip.
Thank you. All right, and we'll see what we can do about getting that 3D printed data somewhere accessible then.
Yeah, I would think he put on Thingiverse or something like that.
Sure.
I'll see if I can find it now.
Thank you. All right, thank you very much, everyone.
Good, thanks again. All right, so that concludes the speakers for this evening. I'll call on our president, Tom Luton, to take care of the announcements. Oh, we got to do fun facts? We'll go right in? Okay.
Before you go straight to the slideshow, I need to check one quick thing. Scroll down, please. I just want to see that I make sure. Yes, okay, good, I did.
Is it coming just there?
Say when. All right, well, thank you very much, and good evening, everyone. Thank you very much to all our presenters this evening, and let's get started with the announcements. So, as we've said before, this is one of two types of meetings that we have here for the Toronto Centre. What you've just seen is one of our recreational astronomy nights, and where we'll have members of the centre make presentations. And 2 weeks from now, we'll have one of our speaker nights in which a professional member of the community will come and talk to us about a project. For those of you watching us live on YouTube, please say hello in the chat box, enter some new questions for presenters. If you're a new member, please introduce yourself. And if you're coming to us from far, far outside the Toronto area, please let us know where you're coming from. So our next recreational astronomy night, our next RAN meeting is going to be online only. It's Wednesday, the 6th of December. Arnold Brody will be discussing the sky this month, followed by Michael Watson, Chasing the Ring of Fire, October's annular solar eclipse, and other umbral thoughts, live here on YouTube. Immediately following this will be the 2023 annual meeting of the Toronto Centre. You'll be receiving official notice of the meeting by email within the next few days of the event, with all the details, the slate of candidates for election, and so forth. Oh, hang on one moment. My apologies. I have somehow skipped over our speakers night. Oh. All right, unfortunately, somehow that slide has been deleted. All right, so our next speaker's night is going to be in 2 weeks' time, on the 15th of November. We will have an astronomer, my apologies, I cannot recall his name off the top of my head, who will be talking to us right here. Presentation will be on YouTube. It will not be live. Anyway, I'd like to have a quick shout out and introduce the folks here in the audience to our new member advisor, Grace, if you'd please stand up. Grace has been recently appointed to the newly created role as RAS Toronto Centre member advisor. Grace has been actively involved in the Toronto Centre for many years, and she is here to help new and existing members become more knowledgeable about and become involved in the Centre's activities and the membership benefits. If you'd like to have a word with her, please reach out to Grace at hello@raskto.ca for any assistance or questions, comments, or suggestions. Grace, thank you again for taking on this role. Now, we've mentioned awards a few times this evening already, and the latest batch of awards for the year 2022-2023 have been decided, and I'd like to quickly go through them. So the Charlene Nordgrove Award for Outstanding Contributions to the Toronto Centre has been awarded to 3 people. As membership secretary, Phil Chow is one of the first people to welcome new members to the RASC Toronto Centre. He also helps to troubleshoot problems with the RASC online membership system and handles questions about membership. For many years, Phil has also been an enthusiastic volunteer at the ECCAR Astronomical Observatory, helping to administer key sets, season passes, and locker and moto leases, participating in work parties, and serving as a weekend supervisor. He also served a term as director of the CAO. The Charlene Nordgrove Award is presented as a recognition of Phil's many contributions to the Toronto Centre. Since joining the RASC Toronto Centre, David Brody has been a great supporter of the ECCAR Astronomical Observatory. During the pandemic shutdown, he helped carry out the monthly winter property inspections and liaise with the Beaver Valley Bruce Trail Association activities. As the CAO reopened, he has driven his tractor from his home in Markdale to the CAO to work on the parking lot and other projects that require heavy equipment, a trip that takes 2 hours each way. David has made valuable and skilled contributions to the CAO committee and at work parties where he has cheerfully mentored other members. The Charlene Nordgrove Award is presented to David in recognition of his contributions to the Toronto Centre. Sam Bosnick is an original member of the Durham Outreach Group of the Education Committee of the RASC Toronto Centre. He has been an enthusiastic participant in the Millennium Square Public Stargazing Program since its inception, treating the public to views of celestial objects with his telescope. Now in his 80s and with another season of Millennium Square events concluded, Sam has announced his retirement from outreach activities. The Charlene Nordgrove Award is awarded to Sam in appreciation of his contributions to astronomical outreach. The Andrew Elvins Award for Promotion of Astronomy. Since she was in grade 1, Arushi Nath has been an enthusiastic student of science and technology, working on citizen science projects in astronomy with her family. She began making presentations of that work in 2018. Now in grade 8, Arushi has become well known for her study of the DART mission and its significance for planetary defense from asteroid collisions. She regularly presents at science fairs at home and abroad and mentions that she got her start as a member of the Toronto Centre. The RASC Toronto Centre presents the Andrew Elvins Award to Arushi in recognition of her achievements in citizen science and promotion of the RASC Toronto Centre. The Bertram J. Topham Award for observing. Charles Young and Alex Argimand first began exploring a revival of the annual Algonquin Adventure to engage group observing activities and a sense of community among members of the RASC Toronto Centre. Their hard work paid off with successful events held in 2021 and 2022. The friendships that arose out of postings to the Toronto Centre email forum were solidified by the face-to-face gatherings at Mew Lake Campground. The Bertram J. Topham Award is presented to Charles and Alex in recognition of their contributions to observing activities in the Toronto Centre. The Ray Thompson Award for Astronomical Imaging. Since joining the RASC Toronto Centre in 2021, Shadrad Pai has enthusiastically explored astroimaging both at home and abroad. She posts regularly as Spyglass to the Toronto Centre Forum, describing her trials and triumphs as she develops her knowledge and skills in the art and science of image acquisition and processing. She also supports other members' imaging activities by commenting positively on their results and providing helpful suggestions. Shradra Pai is a worthy recipient of the Ray Thompson Award. This year, the awards committee did not award the Jesse Ketchum Award or the Ostrander Ramsey Award. And so moving on to the H.A. Winner's Award for Service, also known as the President's Award. At the end of 2019, Adrian Aberdeen joined the RAS Toronto Centre Executive as our new treasurer. 3.5 months later, COVID lockdowns began, resulting in the Toronto Centre losing most revenue sources for 2 fiscal years. Getting through this incredibly difficult time without the centre going bankrupt is a testimony to Adrian's skills as treasurer. What is not generally known is that during this time, Adrian was going through large personal hardship, and yet he stayed on, only retiring this year. The RAS Toronto Centre thereby presents the H.A. Winner's Award to Adrian in recognition of his work as treasurer during the pandemic. Ladies and gentlemen, a round of applause for the award winners. Okay, moving on to what's coming up in the next few weeks. So, City Star Parting, our Long Branch Park pilot project continues. Will take place during the first queer weekend night in November. So the first queer night of the 4th or 5th, the 11th or 12th, the 18th or 19th, the 25th or 26th. Please check our website for a go, no-go decision based on the weather. Bayview Village Park, City Star Parting, the first clear night of the week of November 20th to 23rd, skipping Wednesday. So that's first clear night Monday, Tuesday, or Thursday, 8 p.m. to 11 p.m. Again, please check our website for a go, no-go decision based on the weather. Coming up to DDO in the next few weeks, Saturday, November the 4th, from 9:30 to 11:30 p.m., Gigantic Jupiter, the gas giant at opposition. There's a registration fee of $21 for under the age of 14 and $23.73 for 15 and over. You can register online. The links are at raskto.ca. Coming up on Friday, November 17th, from noon to 2 p.m., is Sun Fun. Registration fee for all ages is $21.63. Again, registration online, and the links can be found at raskto.ca. Saturday, November 18th, 7 to 9 p.m., DDO Astronomy Family Night. Registration fees is $15.69 for up to 14 and 15 or over $17.72. Again, registration required online, and the links are at raskto.ca. DDO Astronomy Speakers Night, Friday, November 24th, from 7 to 9 in person. Dr. Mary Helen Armour, Impact Structures in Ontario. So basically the really big holes in the ground. Registration fee up to the age of 14 is $15.69 and 15 or over $17.72. Registration can be done online, links at raskto.ca. And Saturday, November 25th, 2 sessions, 1 p.m. to 2:30 p.m. and 2:45 to 4:15 p.m. for DDO Planetarium Day. Registration fee, as before, with registration online and links at raskto.ca. And then closing out the month, Sunday sun gazing on Sunday, November 26th, 12:30 to 1 p.m. Registration fees as shown here, and again, links at raskto.ca. Last I've checked, the snow has not yet fallen, so the road is still open at the CAO. Things are largely back to normal, with few exceptions. There is still a maximum of 2 unrelated persons per bedroom who mutually agree to share that room, with masking in common areas is encouraged, but as preferred by those in attendance. We did resume public outreach events over the summer and over the fall. See the CAO bookings page for full details, and please read everything before you make your bookings. We're looking for some job postings. We're looking for a chief editor of Scope. So if you like to edit and write, our Scope newsletter, a bi-monthly publication, is looking for a new editor. We're also looking for a volunteer committee chair, a marketing committee chair, and some committee members. Our EPO outreach committee is always looking for additional help, especially online presenters and telescope camera operators. Reminder, in order to be a volunteer, you first must be a member. Drop me a line at president@raxto.ca for more info. 'Tis the season, RASC memberships. If you wish to attend the annual meeting, you must have your membership up to date. So you can renew, you can sign up online at secure.rax.ca, and gift memberships are available from the national office as it is the holiday season. Just contact them at mempub@rax.ca. Now comes, by some accounts, the most important part, the meeting after the meeting. I'd like to invite you to join us at the Granite Brew Pub, 245 Eglinton Avenue East. That's the corner of Eglinton and Mount Pleasant. There's free underground parking accessible from Mount Pleasant Road. We are usually in the front. For everyone else, I'd like to wish you all a very pleasant evening. Thank you very much for joining us. Please follow us on all the social media forums we've got listed here. If you've been watching us live on YouTube and you like what you saw, please hit the notification bell and ring for notifications. And stay safe and keep looking up. Good night, everyone.